Morning. Um, I hope you had a lovely break. We are going to start a new chapter today. Not a new topic. It's algebra. So, sorry, we're in here third year topics, and then under algebra this year, we've done indices, we've done simultaneous equations, and now inequalities. So not most of the time, but a lot of the time in algebra are like kind of tools to help you deal with other parts of maths, like for example simultaneous equations. I taught you how to do simultaneous equations, but it had a purpose in coordinate geometry because simultaneous equations is how you find the point of intersection of two lines. Yeah. So I think when I showed it to you, I said that you could do it by graphing the lines and finding where they cross, or you could do it simultaneously, as in algebraically, and just get the answer directly without ever having to draw a graph. Okay, so inequalities is similar. Hopefully you remember, I can't remember. We did a bit of inequalities last year when we were doing functions. So it does pop up a bit in functions where it asks you, like there's two graphs on the same page, and it asks you where is graph A greater than graph B type of thing. So it did pop up a little bit, but this is, as always, the ordinary level chapter first. So book 1, chapter 22. So there's a lot, like obviously again, because this is ordinary level, there's a lot of kind of pretty straightforward stuff here. So an inequality, unlike an equals, so when we have, let me try and write this here. When we have an equals, you've been told an exact value. Okay, so I'm just going to scroll to the side a little bit. So if you are given or told, or you figure out whatever, that x equals 6, and equals gives an exact value. Okay, so you have this variable x, and when we solve the equation, we know that x is 6. So for that equation, x is 6. Whereas with inequalities, so for example, an inequality gives a range of values. Okay, so it doesn't give one value, it gives a range or a set of values. Okay, so x being greater than or equal to 7, we are talking about, it depends which number set it comes from, but let's go with natural numbers. It's 7, 8, 9, 10, 11, 12 to infinity. It's a set of answers. So they're not giving us the exact answer, they're saying that x could be any value in this set. Yeah, so that's kind of the difference in kind of theoretically. So in terms of understanding, that's the difference between an equals and an equality. In terms of doing the maths, there's not massive differences. So these are important. We did these, I think, in first year, so we have gone through these before, but it's important to know and be able to read the signs. When we read inequalities, we start from this side and read across it the same way you read English. That's the way we read inequalities. So like something like that. Like I think when you were in primary school, you could read it from either side, but generally speaking, we read it from the left. So 2 is less than x. Or I suppose another way to say it is you read it from the variable. So if you had like something like this, we would read x is greater than or equal to 10. And if you had something like this, again, you would read it from the variable, so it would be x is greater than 11. Do you know what I mean? So when I teach this to you, I would teach you to always bring the x to the left, as opposed to having any kind of, when we do equations, we can bring the x to the left or the right, we just have to isolate it. Whereas when we do inequalities, I tend to bring the x to the left, and it's for that reason, because we read from left to right. Okay, but if you are ever in the situation of the last one, do read from the x. Okay, so if you happen, when you isolate it, that you isolate it on the right hand side, make sure you read from the x. It gets confusing otherwise. Okay, so this goes through numbers being bigger than other numbers, which again we did in first year. The idea of integers. I mean, I think most of you know that 5 is greater than 3 at this stage. Let's hope so. What do they want us to do? True or false? So 5 is greater than 3. 10 is greater than 5. Oh, sorry, that. Don't get complacent. So this reads 10 is less than 5, which is false. -6 is greater than -1. Negative numbers can be confusing because obviously the 6 makes it feel like it's bigger, but because it's a -6. So a -6 is here, a -1 is here. So the -6 is smaller than the -1. So that one's false. And -9 is less than -8. That one's true. Okay. That is really just about reading them and making sure that you're good with the fact that negative integers, like a number like -20, is smaller than -1. But I think we're kind of beyond that. I think most of you have that now. So we've only just done number systems, like right before Christmas. So I'm hoping this is fine. I'll just, rather than go through it here, I'll just go back in here. Right at the start of the chapter, yeah, they show. So these are your number systems. Okay, and these are going to be really, really useful in inequalities because we use them to help plot the graphs. Okay, it's mainly natural numbers, which are positive whole numbers, so whole numbers that are positive, and that's going to be important. The integers, so they're positive and negative, but again, just whole numbers. And then we kind of jump straight to real, which are positive and negative whole numbers, but also decimals and all different types of decimals. So these decimals, the ones that can be written as fractions, and these decimals, the ones that can't. Okay, so it's kind of, there are three main sets for inequalities. So there's your natural numbers, which are whole numbers, positive. Integers, still whole numbers, but now positive and negative. And real numbers are positive and negative. They are the whole numbers, but also the ones in between. So if you look at the number lines, this is kind of what's important here. How do we represent it? So here's a number line for natural numbers. Okay, so notice that 0 is not included because 0 is not a natural number. No negative numbers, so it starts at 1. This arrow here indicates that it'll keep going, so natural numbers don't stop at 5, they will keep going. And then the dots, so see the dots indicate that it's only the whole numbers that are included in the set, so it's just the number 1, the number 2, the number 3, it's nothing in between. Okay, if we look at the integers quickly, so here's the integers. Okay, so this time 0 is included. You have your natural numbers, 1, 2, 3, 4, 5, and so on. So the arrow tells you that it doesn't stop at 5. Because they're integers, as I said, we include the 0, and we also include your negative numbers. And just like on the positive side, it doesn't stop at -5, so we use the arrow to indicate that it's going to continue. And then again, because integers are whole numbers, we use dots to indicate that we're only talking about the whole numbers and not the halves and the quarters in between. Okay, and then real numbers. Sorry, I don't know what happened there. Oh crap. Okay. So real numbers. Here we are. Real numbers are your positive whole numbers, which don't stop at 5. They continue, which we show with an arrow. Your 0 and your negative numbers, which don't stop at -5, which we show with an arrow. Now this time we don't only include the whole numbers. We want to include all the numbers, because real numbers are your quarters and your halves and your eighths and all that, everything in between. So we do that by no dots. We shade the line. Okay, and that's how you show that it's everything. So it's not just dots, it's everything. Yeah? So we'll have a quick look at this example. So graph each of the following inequalities on the number line given. Note x is an element of the different sets, either z, n, or in each case. Okay, so they give us a number line. So A here, I'm going to kind of translate it first, I suppose. So translate that. That says x is greater than -3. And then that says that x is an integer. Yeah? So greater than -3, we're talking about -2, -1, 0, 1, 2. Could we go bigger? We could. So I'll put an arrow to show that it doesn't stop at 2. And then, do we need to shade in the line, or is it only whole numbers? Since it's integers, it's only whole numbers, so we don't shade in the line. Yeah? It said greater than -3 as well, so it didn't give me an option for it to be equal to -3, which is why I didn't include -3. I just went with the first number that's greater than -3, which is -2. Okay? I'm going to, sorry now, I'm just going to draw another one rather than delete that. Okay. Shape. Okay, so we have -5. Okay, that'll do. Keep it exactly the same. Okay, so the second one says, well, it actually says the exact same thing. So that's the exact same. X is greater than -3. But this time it says that x is part of the natural number set. Sorry, I'm writing down here. Okay, so greater than -3, we've established the next number greater than -3 is -2. Yeah? But -2 is not natural, so I wouldn't include it. So the next number greater than -3 is -1. That's not natural, So again, I would not include it. Then 0, but 0 is not natural, so I wouldn't include it. Next number in the line is 1, so 1 is natural. So 1 is greater than minus 3 and it's natural, so I can include that. 2 is greater than minus 3 and natural. 3 is greater than minus 3 and natural. 4 is greater than minus 3 and natural, so it would continue. So I'm going to put an arrow on to indicate that. And then the last thing is, do we need to shade in? As in, do we need to include fractions and decimals? No, we don't, because natural numbers are whole numbers. Okay. So let's do part C. Okay, so I'm just drawing another number line. Don't stop now. Okay, so for C, it's the exact same x is greater than bit. Okay, so x is greater than minus 3 again. But this time, x is real. Yeah? Okay, so greater than minus 3, as we said, is minus 2. And minus 2 is real, so that's fine. Minus 1. Yeah. 0, 1, 2. They're all greater than minus 3 and real. Would it continue? It would. So I'm going to put my arrow down. Yeah? Now, do we, in this situation, where x is real, do we need to include the fractions and the decimals in between the whole numbers? Okay, and the answer here is yes, we do. Real numbers are not whole numbers, they're all the numbers. So what we do is, rather than have the dots, we're going to do this. Yeah. Now what we also have to do is, x is greater than minus 3, and greater than minus 3 in real number terms is like minus 2.999999. Okay, so it wouldn't be appropriate to start shading here at minus 2. So what we do is we put a circle around minus 3, because we know it can't be minus 3 because it says x is greater than minus 3. So it's not minus 3. So we put a circle to indicate that it can't be minus 3, but we shade right up to the circle because we're saying it can be minus 2.99999. It just can't be minus 3. Is that okay? So that's how you use the number lines, and they're like they're part of the answer. So when you do an inequality, when you solve an inequality, you solve it algebraically and then you have to sketch your answer. So this is really important. You have to be able to do this. Okay, so there's another couple of examples there, but it's the same stuff. So I'm going to get you to try a few of these. Draw separate number. Yeah, this is what I want. Okay, so it's this one. So it's draw separate number lines to represent the following inequalities. So these are different numbers from different sets, and you need to represent them on a number line. Yeah? So that's your homework. And on Monday, we will continue with inequalities, and I'll give you your new topic for revision as well. Okay? Do I have you on Monday? I do have you on Monday. Okay, so that's your homework for Monday. I'm going to add it in. Oh, no. Sorry. I'm going to add it in here. So it's Friday 7th. Alright, so that is your homework due for Monday. Alright guys, have a nice weekend.